Wow, we were on hydrocarbons, right? Cyclic hydrocarbons, to be accurate. Saturated hydrocarbons containing molecules arranged in a close ring and are naphthenic, naphthenic hydrocarbons. Each member consists of a close ring of carbon atoms with two hydrogen atoms attached to each carbon atom. The first member of the series is cyclopropane, CH2. 3. Sorry, don't want to fuck up that one. The naphthenes are important constituents of crude petroleum found in Russia, Oklahoma, Texas, and California. Okay, the most important group of cyclic compounds are the unsaturated aromatic hydrocarbons consisting of liquid and solid hydrocarbons which anthracene, benzene, nanthrene, which anthracene, benzene, benthrene, naphthalene, and toluene are important members. See atomic compounds. We will. Terpene hydrocarbons are naturally occurring substances, generally having the empirical formula C10H16. Found in many volatile oils obtained by the distillation of plants, they include both open chain and cyclical compounds. Camphor and pinene being among the important cyclical terpenes. Wow. Right? That's cool. I want to hear someone that actually knows some shit tell me about some of that. But no, I have to listen to some retards. For the most part, I've heard some very smart people talk to me about this. So, hearing a lot of people talk to me about this is idiotic, right? Hydrochloric acid, that is censored. Cortisone, suprarenal gland. Yeah, I'm supposed to see those for a hydrocortisone. Right. Cyanic acid, yeah, that's censored as well. Right. Hydrodynamics, see hydromechanics, we went through all that, right? Last video. Hydrogen, right? So we're doing some H's, right? GR, water former, right? So that's its derivative, right? Hydrogen means water former, right? The lightest of all elements, so if you look at your little period, it's the first one at the top left, right? With atomic number 1, that's why it's there, it's number 1, baby, right? Atomic weight 1.0081, symbol H. It was confused with other gases until Henry Cavendish, QB, we'll see him in H. Or an H, we'll have to go back to A. I'm still doing A's, but I'm jumping around, right? So we'll see this guy sooner or later. Demonstrated in 1766. Wow. 10 years before America. He was finding out what hydrogen was, right? That was evolved by the action of sulfuric acid on metals and also showed at later date that it was independent substance that combined with oxygen to form water. What a smart guy. Henry Cavendish realized that H2O is H2O. Joseph Priestley, QE, we'll see him later, named the gas inflammable air in 1781. Well, if I know something about hydrogen, he's a liar, but I still like calling it that. That's funny. Like, you call it that today and people look at you like you're a retard, but fucking whatever. In 1781, and Antoine Lorette Lavoisier, QB, we'll see him named later, renamed it hydrogen. See chemistry history, we will. Free hydrogen is found only in very small traces in the atmosphere, but solar and stellar spectra show that it occurs in the sun and other stars. Alright, so here's where I'm going to put some of my input because I like this stuff, right? But this is 70 years old. There's a little bit more to this that we know, right? Yes, there are very small traces in the atmosphere, but we also dump and waste a lot of hydrogen into the atmosphere. And it is light enough that it goes out into space and then vaporizes in the fucking nothingness. Right, but a lot of people don't realize this, and wasted hydrogen is wasted hydrogen, right? I can do a lot with hydrogen, but oh well. Right? Oh well. And okay, sun and other stars. Well, a lot of Americans don't know what a fucking star is, or the sun, so in the context like this, right? So you can't expect them to go, oh fucking yeah, that's that thing, right? No, they just, oh my god. Anyways, yeah, so we hypothesize that the sun is like 22 to 44% fucking helium or something, and the rest is different levels of hydrogen and isotopes of hydrogen that are, we could hypothetically calculate, and we probably have, but the calculations are quantified, not sampled. And considering current technology, yeah. Just saying, overbloated stipulations. Alright. In combination with other elements, it is very widely distributed on Earth. Yes, it is. The most important and abundant compound is water, H2O. Who would have guessed? It is a component of all constituents of living matter as well as many minerals. Yep, we're made out of a lot of it, right? It forms an essential part of all hydrocarbons. QB, we talked about that. We just finished that, right? And a vast variety of other organic substances. All acids contain hydrogen. No, you can't say that. The distinguishing characteristic of an acid is its dissociation upon going into solution to yield hydrogen ions. So that's some mumbo jumbo lingo that you probably don't need to know, and if you do know, then you do know, right? At ordinary temperatures, hydrogen is a colorless, tasteless, odorless gas with a density about 7/100th that of air. It is highly inflammable. Hydrogen doesn't flame up. I'd like to put that to the test. Like most gaseous elements, it is diatomic. Its molecules contain two atoms, but it's dissociated into three atoms. At high temperatures, hydrogen has a lower boiling point, negative 252.7 degrees Celsius. That's negative 422.9 degrees Fahrenheit. And melting point, so it won't be a solid, right? At 259.1 Celsius and 434.4 Fahrenheit. Or so the book says, right? Have we quantified the exact numbers in 70 years? Maybe this is right. Oh, different variables, characteristics, stats, depending on X factors and blah 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 blah. Right? Than any other substance except helium. Wow. QB, liquid hydrogen, first obtained by Sir James Dewar. See cryogenics. And we can't talk about cryogenics. We're not to Walt Disney yet. Oh, never mind. That's a different story. Okay. That's me being crazy given, I don't know, story. All right. In 1898, the colorless, light blue in thick layers, has a specific gravity of 0.079. When allowed to evaporate rapidly under reduced pressure, it freezes into a colorless solid. Cool. Hydrogen is a mixture of two allotropic forms, orthohydrogen and parahydrogen. Right? Ordinary hydrogen containing about 3 or 4 of the ortho form or 1/4 of the para form. Right? The melting point and boiling point of the two forms differ slightly from those of ordinary hydrogen, particularly parahydrogen is obtained by absorbing ordinary hydrogen on X at about negative 225 degrees Celsius, negative 370 degrees Fahrenheit. Right, and that's halfway through hydrogen. I'm going to stop here. Right, this is fun. Right. Oh, that's what I like talking about, guys. Right. And I like hearing the motherfucker say something, but man, they better know what they're talking about. Oh, y'all have a good one, guys. I'm bored.